Hello and welcome to this lecture on VBA Unit 4. In this video we will be looking at if statements, and we will also spend some time talking about user-created functions near the end. Now, if statements are very powerful because they give you as a programmer the ability to make decisions in your code. And the best way to understand if statements, I believe, is to look at lots of code examples, and that's what we're going to be doing in this lecture and this assignment in particular. So, one type of if statement is what's called a single line if statement. It does not have an end if. The entire statement appears on a single line. So here's some code that shows us an example of two single line if statements. This code replicates tossing a coin. And you can see the subroutine. The name of the subroutine is coin toss. It's got two variables, an integer for toss, and then a string that's called text string or text str. Toss variable is on the left hand of an assignment statement, so the toss variable gets assigned application dot rand between 1, 2. What rand between is it's the Excel function, and you can do this in Excel. You can go into a cell on Excel and type rand between, and it requires two arguments, the lower bound and the upper bound, and it'll give you a whole number between, an integer between the lower bound and the upper bound inclusively. So it'll be a 1 or a 2. If it was 1 to 10, you would have a value between 1 and 10. 0 to 10, it would be an integer between 0 and 10, and so on, between 55 and 75. Whatever you want, you pick two integer values, and it gives you a random value between those, including the endpoints. The application dot in front of that, you have to type that to let VBA know that you're talking about the built-in Excel function and not a routine that you've written yourself elsewhere in the code inside the module. So toss gets a 1 or a 2. Now you don't know what the value is going to be, and it's going to be different every time you run the program. So there's some if statements here, some single line if statements that are going to say either heads or tails, where 1 is a heads and 2 is tails. And the way the if statement works, it's pretty clear, I think, right? If some condition, and conditions use the relational operators greater than, less than, equal, and you can do, and that's all we're doing at this point. We'll get more complicated in a future unit. But for now, we're just using equals or greater than or less than. If condition, then do something. In this case, if it's a 1, what I want to do is I want to take the string heads, and it's a string literal inside of double quotes, and I'm copying that into the variable text string, text str, which was declared to be a string variable, right? So if condition, then do something. Now, if the condition is toss equals 2, then do something else. And when we get done, we will have either assigned heads or tails to the message, the string variable text string, and then we message box that out. Okay, so let's pull up Excel and just kind of see how this works. So I'll start a new copy of Excel, pull up my spreadsheet here. We'll do this inside the Visual Basic Editor. We'll write this code inside of a module, and what we call this, oops, looking at the code, is called coin toss. So it automatically puts in the parameters, the parentheses, which are how we pass data into our subroutine. We don't need to do that in this case. It puts the end sub in for me. And it's always a good idea to indent inside a block. So the sub and the end sub creates a block, and everything inside that block, the contents of that block, should be indented. It's not required, but it makes for good design. And we declare a variable toss as an integer, and we declared a variable text string, what was it called? Yeah, text string, as a type string. Toss is equal to application dot rand between from 1 to 2, and a single line if statement. If some condition, toss is equal to 1, then do something. Text string is equal to heads. And there's no end if. We'll see something called an end if later, but we don't have an end if on a single line if statement. The statement starts here, and it the if statement ends when the line ends. Then I have another if statement. Blank spaces don't matter, they're optional. The white space here and the white space here, all those blank spaces don't matter, they're just for readability. Okay. So we've declared this. It's always a good idea at the top of your module, just one time, to say option explicit at the top of each module that you have. But I can have 5, 6, 10 subroutines and functions or anything inside this module. I only have to say option explicit once at the top of, in this case, module 1. That'll make sure that the variables are declared when I use them. Place the cursor in here and press run, or go to the F5 key as a shortcut, or hit the green little run arrow button, and this code will run, and it'll say tails. If I run it again, I'll get tails. If I run it again, I'll get heads. If I run it again, I'll get heads. If I run it again, right? And every time I get it, I'm getting a different value, or I'm getting a 50-50 chance of getting heads or getting tails. So what this is showing us, what we're seeing here, is the use of an if statement. There's another slightly more complicated single line if statement where again we're using the Excel application function, built-in function, rand between from 1 to 6, which is a good example of rolling a regular 6-sided die. And I've got two variables, dice1 and dice2, that are both integers, and they're going to hold a random value from 1 to 6 and a random value from 1 to 6. And I'm going to test, is the first roll bigger than the second? Is the first roll less than the second? Or is the first roll equal to the second? So these are three separate if statements. If condition, then do something. If condition, then do something. If condition, then do something. And in this case, the do something is, I'm creating a text string, again, that I'm going to message box when we're done. But the text string is being a little more complicated. It's got the dice1 variable. So when this displays, it'll give you the value of that variable concatenated with the text greater than concatenated with the variable dice2. So it'll say something like 5 is greater than 3, or 3 is less than 5, or 5 equal to 5, depending on whatever the values are for dice1 and dice2 on that particular run. Just as a bit of reminder of what we've said before, when you concatenate strings together, you have to watch out for the strings. You need to insert the white space between them. So this becomes a 5. If I want there to be a space between the 5 and the word greater than, I have to include that space inside my double quotes. And greater than 6 or greater than 4, I have to include a space after the than inside the double quotes, and that space will appear. So the result will be 5 space greater than space 3. And I want to make sure I have those spaces there when I'm concatenating strings together like this. Now I could type that out again, but I'm just going to pull it up already written and save a little bit of time here. So here we go. I've added a comment here for single line if statements because this is our second example involving a single line if statement, and I've typed in the code that you see on the document for this week. We're using rand between again. We're doing a text string is getting a value with white spaces between it and outputting it. So I think we've talked about everything involved in this. Let's go ahead and run it and just see what it does. So I run this, 5 is greater than 4, and I run it, 4 is greater than 2, 6 is greater than 4, right? 3 is less than. I'll run it here. And one of these times I should get an equals, probably about 1 in 6 actually. Exactly 1 in 6 on average. Doesn't mean any specific instance. Oops. Three is equal to 3. Okay, so that's what this code does. What you're going to do for your homework this week is you're going to type in all of this code. The best way to get familiar with if statements is just repetition. So I just want you to type in both of these single line if statement programs as the first of your homework problems. Getting back to our document here. Then we start talking about multi-line if statements. A lot of the time when we write if statements, it spans multiple lines in the editor. And when we have a multi-line if statement, we have to have an end if to end the block. Just like a sub has an end sub to end the block, an if statement, it'll still begin if condition then, but the if statement will continue multiple lines and end later in the code with the end if keywords. And if condition then, carriage return. And you start the multi-line statement with those if condition then and carriage return. And you use these other keywords, else statement, if else, and end if. And there's many combinations of that, and the best way to understand it is to just look at some code. So here we're looking at an if then else example. The name of this subroutine is even odd. We declare an integer called value. We let value be prompted by the user with an input box. Please enter a value. And if value mod 2 equals 0, it's even, otherwise it's odd. Now remember what the mod function does. It's integer remainder. So you take as many 2's out of the number as you can. If the number was 8, I could take 2, 4, 6, 8 out of 8. If the value was 20, I could take 10 2's out of 20. Right? And mod is what's left over. So after you keep taking out all the 2's you can, if nothing's left over, that means it was an even value. And after you take out all the 2's you can take out, if there's still something left, then it was an odd integer. Okay. So the code for that is here inside our VBA. So we have now some if then else code. And here's the if then else code for even odd. And I press the F5 key to run that. So if I type in 17, that's odd. And if I type in 18, using the F5 key to run, I get 18 is even. Okay. Going back to our PDF, here's another example of an if then else multi-line if statement, where we're testing two inputs. The user enters two numbers, and we're outputting either the values are equal or the values are not equal. And here's the code for that. Exactly like you see in your PDF. When you run this code, it'll say, please enter a value. So 5 and 5, the values are equal. But if I run it again and I say 5 and 6, I get the values are not equal. Then we're looking at an if-else if statement. Now the thing that an if-else if statement does is it's a multi-line if statement, right? It begins here with the if statement, if condition then, and it ends down here with the end if. So that's our multi-line if statement. But the way it works, if condition then do something, and this can be the block between the then and the next keyword, whatever it is. It can be one thing, it can be 2, 3, 5, or 10 things. It's a block, as big or as small as you want it to be. But after the true block, following the then, by having else if, and the keyword is there's an if in there again, you have another condition. Well, what if, so here's a condition, count equals 1, then say you're holding no items. Well, what if, or else if, count equals, sorry, that was 0. Count equals 1, then you're holding 1 item. Else, and we don't get to this final else unless all the ifs and else ifs before it were false. So logically, if it wasn't 0 and it wasn't 1, the only thing left is to say you're holding 2 items, 3 items, 70 items, 71 items, whatever it is, and it's going to be a plural items with an S, right? So no items, 1 item singular, and 2, 3, or 4 items. F5 to run. If you say 5, you've got 5 items. If I say 1, you get 1 item. If you say 0, you get no items. Another example of a multi-line if then else. If hours earned is less than 30, then, here's the first condition. Else if, here's another condition. What if hours is less than 60? Then, what if hours is less than 90? And we don't do, as soon as you find a true match in your if statement, it's done. It jumps to the end if and it's done. So if you're a freshman, you won't even do these other things. You won't even test the 60 or the 90 or the final else. If statements, once they find their match, their first true condition, they end at that point. So let's run that and just see. 65, that would make you a junior. If I was 95, that would make you a senior. 18, that would be a freshman. And 40 would be a sophomore. The last if statement that we have, let's go back to our PDF here. So all of this is in your PDF, the holding subroutine, the college status subroutine, these are all in your PDF document, and you're going to type those in. This is your homework, is to type in these programs and run the programs and get them to work. So it's just time on task, and it'll build your confidence, and you'll feel a lot better, I'm sure, by the time you spend writing and getting these programs to work. So here we have a classic problem. It's an overtime pay problem. Right? Your pay, if you work 30 hours and you get $10 an hour, you know what your pay is. 30 times 10, $300. But if you work 50 hours at $10 an hour, you say, well, that's 50 times 10, 500. But part of you may be thinking, well, wait a second, I worked more than 40 hours this week. I should be getting some overtime for the hours I worked more than 40. If I work 50 hours at $10 an hour, I should get paid more than 500. I should have 10 hours of overtime, which is time and a half, right? I should get paid $550. Well, we can do that in Excel. We can use the different formulas. But the thing is, hours times pay is the correct formula if we work 30 hours. But the more complicated formula that takes into account overtime, it's the correct formula only if you're working more than 40 hours. Right? So here's the program that can do this. 3 variables, hours, rate, and pay. The first 2 are input variables. Pay is a calculated variable that will calculate and then display. We get our input variables using dialog boxes, input box, with an appropriate prompt. Please enter hours worked this week and enter hourly pay rate. We have a multi-line if-then-else statement. If a condition, hours is less than 40, then do something, calculate pay using the simple hours times rate formula. If hours less than 40 is false, go to the else branch and do something. Calculate pay using the more complicated overtime formula. 40 hours at the regular rate plus hours minus 40, your overtime hours, times rate times 1.5, the overtime rate. Regardless of which way you calculated pay, when you're done, you're going to message box pay due is, and then a space inside the quotes because I want that space to be in my output. And I'm concatenating that with the variable pay. And I'm using this statement here, format currency. The purpose of this format currency is to take a double value, a numeric value, but print it out formatted as currency, just like Excel does, right? So in Excel, I can type in a value here, 54. That's actually the value in the cell is 54, but I can format it to be currency. And it's got a leading dollar sign, and it's got decimal place and 2 decimals. The cell still is just a 54, right? The actual value there is a 54. The dollar sign, the formatting is, let me see, there's currency and there's accounting. There's actually 2 of these. Try to see which one of these has a dollar sign that floats. See, the dollar sign is floating there. In our spreadsheet, we don't have the weird floating there. And I don't see exactly where the command is to make the dollar sign not float like that. Oops. That's the problem. There's your problem right there. You're clicking on the wrong cell. I was formatting this blank cell. So it's the currency format where the dollar sign is plush against the number. It takes a regular 54 and makes it have 2 decimal places. And if there are thousands place, right, 54,000, it'll put the comma in automatically as necessary. So as you need commas, it'll add the commas in for you. It'll give you 2 decimal places automatically, and it'll round. So if this was 44.399, it'll round that up to 3999, round up to 40. So the same way that formatting currency works in a spreadsheet is the way that format currency works in this command. It will take that value due, which is just a double, but it will make it print out like the formatted currency in a spreadsheet. So if I work 30 hours at $10 an hour, 300, right? But if I work 50 hours at $10 an hour, I'm getting the extra pay, $550 instead of $500. Okay, so that's a big chunk of what you're going to be doing for me, typing those in and getting those to work. But there's one more topic this week that I wanted to look at, just because it's kind of neat and interesting and shows off the power of VBA and something you might make use of in the future. The idea that you can write your own functions that you can then use in the spreadsheet, just like the built-in functions. The built-in functions, sum, average, min, max, future value, present value, and hundreds more, right? Excel has a massive amount of built-in functions. And if we said, here's a cell and I want to type a function into this, I can use some of the common ones that are built in. I can go under more functions and see some most recently used and financial and date and math and all these. If I just go under all, just give me all the functions, I can see that there's one called ABS, which returns the absolute value of a number without a sign. There's ACCRINT, which returns the accrued interest for a security that pays over a periodic interest rate. There's an ACCRINTM, returns the accrued interest for a security that pays interest at maturity, and on and on and on. If I just hold the mouse down here, we'll start scrolling through all these pre-built functions that exist inside of Excel. And we can use any of these functions in our spreadsheet by saying equals in the name of the function to get Excel's attention, and then pass the arguments that it expects, and it'll do the calculations for us. So Excel has lots and 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 lots of formulas. Any formula that's printed in a college textbook, more than likely Excel has that formula. But what if you wanted to make your own that wasn't in there? For some reason you want to customize your own. Well, we can do that. Okay, we can do that by going into our developer window, and we have to write it in a module. You can have code specific to a sheet or specific to the workbook, but for you to use it as a function, it needs to be written in a module block. And here's 2 functions that we have that I have you type in as part of this assignment. A function area and a function perimeter. Now, what is a function? A function returns a value. The thing that stands out in your mind when you think about a function, whether it's math class or certainly when it comes to a programming class, functions return values. You call a function, you get a result. The rand between that we were looking at is a function. It gives you a value between 1 and 10 or 1 and 6 or whatever your arguments are. Sum is a function. It gives you a value. It gives you the sum of all the cells. Average is a function. It gives you a value. It gives you the average of all the values. Right? A function returns a value. So the difference between a function and a sub is that not just the keyword function, keyword sub, but function has the name of the function. It has the arguments in parentheses. In this case, we are passing it information, but it has at the end this. It has a data type. A function has a data type because a function returns a value. This function area is going to return a double. I'm going to give it 2 doubles. The first is the width and the second is the height, and it's going to return a double. And the way a function works is you write the structure of a function exactly like you write the structure of a subroutine. It's just that the name of the function, whatever the name of the function is treated like a variable as double. and somewhere you have that function name on the left-hand side of an assignment statement, and you assign something to the function name. In this case, width times height, I'm assigning that to area. So what that does is I can now go to my spreadsheet and I can say equals area, and it knows about area, the routine that I created. Now it's not giving me the context menu to pop up here. We can do some additional code to make the user see that, but we know that it has two arguments, width and height. So if I say 5 and 6 and I press enter, it does that function. The code that I wrote executes, and it gives me the value of 5 times 6, 30 as the value that gets returned. Perimeter is the same way. Function perimeter returns a double. So somewhere in this function, I'm going to use the function name perimeter on the left-hand side of an assignment statement, and I'm going to assign it a value of type double, a numeric value. Width plus height plus height, or width times 2 plus height times 2. Right? We're just adding, you're walking, a perimeter is walking around the fence. Right? So you walk the length, and you walk the one side, and you walk the back length, and you walk the other side. Right? It's 1, 2, 3, 4. So, and since it's a square, we're assuming a square perimeter here. The perimeter of a square, the width and the height are the same. So it's really width times width and height plus height times height. Or width times 2 plus height times 2. Okay, sorry, this isn't a class on algebra and perimeters. The point is that if you have the correct formula, you can then, in your spreadsheet, perimeter, so 10 and 8 would be 10 plus 10 plus 8 plus 8, all right, be 36. So that's kind of neat. And what I'd like you to do is just build this, and I've just formatted. This isn't anything special. This is just typed in the text area and typed in the text perimeter and typed in a 1, 2, 3, 4, 5, 6, right, and then formatted those to look nice. If I take the formatting out, if I turn off the fill, you can see that there's nothing there. Right, it's just text in the sheet, but I like the formatting because I think it makes it look better. And I'm going to use this area formula to say what's the area of this times this. And it tells me that the value is, why did that gripe? No, I'm sorry, not times. Comma. Commas separate items in a list. And I'm doing the area of that cell, comma, that cell. Right? So B2 and A3. And I get, if I had a 1 inch by 1 inch square, the area would be length times height would be 1. Now I want to copy this, and right now this isn't going to work when I copy it. Okay. So I try to copy it, and I don't get the right values. A 6 inch by 1 inch square does not have an area of 720 inches. All right, so that's not the right way to copy. What I need to do before I copy this is I need to recognize that as I copy to the right, I want my A value to always stay a 1. Right? So I'm going to do a mixed reference where I want the A value to be fixed. And as I copy down, so that'll copy to the right will work now. Okay. 6 times 1 is 6. But when I copy down, it doesn't work. All right. So I've still got the situation. When I copy down, I want this, the value for row 2 to always be fixed. Because column A has my fixed value and row 2 has my fixed values. So I make the row 2 prefixed with a $sign. I make column A prefixed with a $sign. And now when I copy that, it's going to work for all my values. So a 5 by 4 has a perimeter, has an area of 20, and that's correct. And let's do the same here for perimeter. Comma, that cell, comma, this cell. Those are my arguments. Those are the two values that I'm passing in to the perimeter function. And if it's 1 foot or by 1 foot, then it's 4 feet to walk around, or 1 inch by 1 inch, it's 4 inches, right? So the units don't matter as long as they're the same, as long as they're inches or feet. But before I copy this, I want the value in column A to be unchanging, and I want the value in row 10 to be unchanging. So I used a mix reference. I can copy those over and copy those down. And now 4 and 5, that perimeter 4 and 5 is 18, right? Because 4 and 4 and 5 and 5. So that's kind of a neat thing that we can do. We can write VBA code to create a function, functions return a value, that we can then use those functions as we build our spreadsheets. And that's a skill that might be useful to you as a VBA skill that might be useful to you in the future when working with a spreadsheet. So your homework is to write the code for the single line if statements, coin, toss, and roll 2 dice. Your second assignment is to write the if, then, else programs of even, odd, and equal test. Your third homework is to write the if, else if examples of holding and college status. I also want you to write the overtime program that we saw for one formula for pay, regular pay less than 40 hours, another for pay more than 40 hours. And finally, I want you to write the functions for area and perimeter, and then go to your spreadsheet and use those functions to fill in the tables that we just did. So this is, in a way, one of the easier assignments we're going to have, because I'm not asking you to do anything super challenging, original, but I just want you to get the repetition of sitting down and writing code and testing the code and seeing how it works, and writing code and testing code and seeing how it works, using various versions of the if statement, single line if statement, if then else, if else if statement, and doing 2 examples with each one of those, plus the overtime, plus the functions, and seeing how your functions work. This will be a good boost of your confidence by going through and typing this code, and we'll continue building as we go.